All right, we are going to be talking about CPCTC proofs. CPCTC stands for corresponding parts of congruent triangles are congruent. The main idea here is that when you're trying to prove that segments or angles are congruent, you can first prove that the triangles that they are in are congruent, and then because congruent triangles have congruent parts that match up, you can make claims about the segments or the angles. We're going to do an example together. The example that we're going to prove together is that opposite sides in a parallelogram are congruent. Anytime that we want to prove something, we want to start off by rewriting it in if-then form. So this statement rewritten to if-then form would be if a shape is a parallelogram, then its opposite sides are congruent. And we also want to identify the hypothesis and the conclusion here. The hypothesis is that a shape is a parallelogram. The conclusion is that its opposite sides are congruent. And some important vocabulary from this theorem to recognize: parallelogram is a quadrilateral whose opposite sides are parallel, and congruent means same measure. So let's set up this proof. Reminder that the theorem we want to prove says if a shape is a parallelogram, then its opposite sides are congruent. The hypothesis here was a shape is a parallelogram. The hypothesis is where we get our given information from, so we need to give ourselves a parallelogram, which we will call ABCD, and here it is. The conclusion is that its opposite sides are congruent. That's where we get our what to prove statement. So we are going to prove AB is congruent to CD and AD is congruent to BC. So once again, we've got ABCD as a parallelogram. That's the given information that we start with. We're going to prove AB is congruent to CD and AD is congruent to BC. So that's both pairs of opposite sides being congruent. In order to actually do this proof, you might be thinking, hey, wait a minute, I was told we were going to be doing triangles, and I don't see any triangles there. We can make a triangle or two for ourselves by drawing a diagonal through this shape. So we're going to draw a diagonal so that we have some triangles to work with so that we can do a CPCTC proof. We're going to make a flowchart proof. Every time we're doing a proof, we always start with the given information, which says that ABCD is a parallelogram. From there, thinking back to what we had said about vocabulary earlier, we can say, hey, wait a minute, parallelograms have opposite sides parallel, which gives us two separate statements. AB is parallel to CD. Because of the definition of a parallelogram, those are opposite sides. And AD is parallel to BC, still because of the definition of a parallelogram, because those are still opposite sides. Then, looking at that first pair of parallel lines, AB and CD, we can say, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. That's one of the theorems that we proved in class. The alternate interior angles here are BAC and ACD. So we can say that those are congruent by the alternate interior angles theorem. Then we can do the same thing with the other pair of parallel lines. So looking at AD and BC as our parallel lines, we would have angle DAC and angle ACB are the alternate interior angles. So the alternate interior angle theorem also tells us that those are congruent to each other. Now, our goal, first, is to be able to say that we have congruent triangles here. Right now, we're able to say we've got a pair of congruent angles in these triangles. We've got another pair of congruent angles in these triangles. We need a third piece of information in order to say that these triangles are congruent. And that third piece of information is going to come from that diagonal that we drew. We can say AC is congruent to AC by the reflexive property, because remember, the reflexive property says that things are congruent to themselves. So because that side exists in both triangles, that gives us our third piece of information, a congruent side between the angles that we're talking about. So we can say that triangle ABC is congruent to triangle CDA by angle side angle. Once we've said that those triangles are congruent, we can say, hey, AB and CD are the short sides in their respective triangles and the first two letters in each of the names that we've given here. So AB is congruent to CD because corresponding parts of congruent triangles are congruent. And then AD and BC are the longer but not longest sides in those triangles. And that's also the second and third letters in each of the names we've given here. So we can say that AD is congruent to BC because corresponding parts of congruent triangles are congruent. So once again, to summarize, when we wanted to prove something about a parallelogram, we were able to draw a diagonal to split it into two triangles. We were able to prove that those two triangles were congruent to each other. And then once we knew that those two triangles were congruent to each other, we were able to draw conclusions about the sides that we were interested in originally.